A lot of time passed between Darwin's voyage on the HMS Beagle and when he finally published his ideas about natural selection. One reason why so much time passed is because Darwin had to overcome religious ideas that contradicted his own ideas about evolution. To overcome ideas existing at the time, Darwin wanted to build as convincing of an argument as he could using scientific evidence. Video 2.2 will discuss Darwin's scientific evidence in support of natural selection, as well as a competing idea of his time, that of Jean-Baptiste Lamarck. This video will cover these two important goals. Pause the video to check them out. First, let's talk about a competing theory for Darwin, Lamarck's theory of evolution by acquired traits. Lamarck's theory already had a full head of steam by the time Darwin was born, being published in 1809. Think of Lamarck's idea of the process of evolution as the theory of acquired traits. Now, the basic principles of this idea were, first, the idea of use and disuse affected traits. In other words, an organism's traits become enhanced or diminished by how the organisms use them. Now, the second part of this is inheritance of acquired traits. So what this means is that traits which develop during the lifetime of an organism can be passed on to its offspring. Let's learn more about Lamarck with his classic example of why giraffes have long necks. As you probably know, the long necks of giraffes are advantageous because long necks mean that giraffes can reach a food source of leaves high in the trees. Now, Lamarck proposed that since giraffes use their neck to constantly reach for high leaves, giraffes' necks get slightly longer during their lifetime. Then, this longer neck is passed on to the offspring of the giraffe. Now, this doesn't mean that giraffes went from having short necks to long necks, all in just one generation, but Lamarck hypothesized that the long neck took many generations. In each generation, giraffes would stretch their neck to get food. Those giraffes would get longer necks than before and then pass those longer than before necks onto their offspring, so that over many generations, giraffes' necks got longer. We know now that Lamarck's theory was incorrect, but the fact that Lamarck's theory was even published meant that the theory had some traction in the scientific community. And let's face it, we're still talking about Lamarck today, almost 200 years later, so that's got to mean something. Anyway, the reason I want to talk about Lamarck is to highlight an important difference between Lamarck and Darwin. Lamarck postulated that giraffes developed longer necks during their lives and passed on the acquired trait of longer necks to their offspring. Darwin's ideas say that giraffes are born with variable characteristics of neck size. In Darwin's theory, you get what you get at birth, and then you pass on those traits if those traits make you lucky enough to survive the struggle of life. Let's look at that another way. Now, Lamarck would say that individuals can change during their lives and that the individuals live and reproduce based on the traits they have at birth or develop during their lifetime. Both of those types of traits an organism is born with, and acquired traits can be passed on. In Darwin's theory, though, organisms are only selected to survive and reproduce based on the traits that they're born with. Sure, an organism can use behaviors and an organism's physiology can change, but the only traits an organism can pass on are traits that the organism is born with. And that's what Darwin said. One thing they did both agree on, however, is the pace of evolution. Both understood that evolution took millions of years. The idea that Earth was so old defied widespread religious beliefs of the time. I think a clear example of a blacksmith can debunk Lamarck's ideas in your mind once and for all. Check out this blacksmith. He's a big dude with big muscles from blacksmithing all day with his big old hammer and his big mug of Gatorade or whatever. And from blacksmithing, this guy's hammer arm muscles would get huge during his lifetime. You know, use and disuse. The blacksmith would acquire big arms during his lifetime, and those muscles would be passed on to his offspring. But then you'd expect children of blacksmith families to look something like this, but that's pretty ridiculous, and that's not the case. The fact is that Lamarck had a lot of good ideas, but his ideas just didn't hold up to scientific evidence. Here's the thing, though. Lamarck's ideas were critical to advancing scientific thought. Lamarck's ideas helped counter the enormous push of religious beliefs at the time. Lamarck planted seeds that species were not created perfectly by a divine being, but changed over time. Lamarck knew that the natural environment played a role in shaping organisms. And finally, Lamarck helped popularize the idea that evolution was a process that took a really long time. Not thousands of years, but millions of years. When Darwin rolled out natural selection, he had four main lines of scientific evidence to support his theory: artificial selection, island biogeography, fossils, and homologous anatomical structures. Artificial selection is when man selects breeders and shapes organisms to do what people want them to do. A classic example of artificial selection is domestic dogs. All dogs originated from wolves that were first domesticated 12 to 15,000 years ago. And by selecting dogs with extreme characteristics to match certain jobs, people created all of these different extreme dog breeds. In nature, the process of evolution takes millions of years most of the time, but artificial selection accelerates that process. Another example of artificial selection is breeding of pigeons. Pigeons were more popular as pets in Darwin's time, and Darwin was actually a pigeon breeder himself. All of these pigeon varieties were made by man selecting breeder pigeons with interesting variable characteristics. One final example of artificial selection in agriculture is selective breeding of wild mustard plants to make all of these varieties of vegetables that we have today. Cauliflower, broccoli, cabbage, Brussels sprouts, kale, and kohlrabi are all descendants of the same plants, where farmers used artificial selection to select useful varieties. So, artificial selection and natural selection are kind of the same process. Both involve selection of which organisms get to be breeders, but the selection pressure is different. In artificial selection, people select breeders to shape the organisms to do specific jobs. In natural selection, natural conditions select breeders, and that shapes the organisms to better fit those natural conditions. Either way, the organisms change over time. The critical difference is the amount of time it takes. Since man uses such extreme and aggressive selection, artificial selection rapidly accelerates the pace of change. Now, Darwin knew people would have a hard time getting on board with natural selection since natural selection takes so long, way longer than a human lifetime. But the transformation of wolves into dogs, shaping of pigeons, and selective breeding of wild mustard was part of documented human history that people accepted. By laying out the similarities of artificial selection and natural selection, Darwin hoped that people would see that selection could shape organisms. Man's aggressive selection causes evolution in a short time that people understand, so why can't nature do this process just with a longer time frame? The next line of evidence from Darwin is island biogeography. Island biogeography refers to the geographic distribution of species. In the Galapagos Islands, Darwin found a lot of endemic species, meaning that certain species were found only on certain islands. But here's how endemics helped Darwin piece his story together. Darwin found that different islands had closely related species to each other and to the mainland. Famous examples include Darwin's finches and Galapagos tortoises. Even though these species are closely related, each has adaptations that increase its fitness for its specific area. The beaks of finches adapted over time to fit their food source. The shells of Galapagos tortoises match up with their food source too. This tortoise has a saddleback shell, allowing the tortoise to reach higher up for its food that's higher up. Organisms evolve over time to match their environmental conditions. Darwin used island biogeography and endemic species to show that organisms match up with their natural conditions to survive best. Closely related organisms have specific adaptations that fit the features of their different environment. In other words, Darwin used island biogeography to emphasize the role of nature in shaping organisms by evolution. The next piece of scientific evidence from Darwin was fossils. How fossils work is by something called the law of superposition. The law of superposition says that older fossils are on the bottom and more recent fossils are on the top of rock layers. And this means that fossils in an area can be organized and lined up from bottom to top to make a timeline of evolution. Now, Darwin anticipated pushback against natural selection because people can't see evolution. The reason people can't see evolution is because evolution takes a long time, usually millions of years. For Darwin, using the scientific evidence of fossils created a timeline for evolution that lasted millions of years, and you could line up those fossils so people could see that timeline with their own eyes. The last line of scientific evidence is homologous anatomical structures. A homologous structure is a structure in different organisms that has a common evolutionary origin. An example is a forelimb or arm. Here are the forelimbs from humans, cats, whales, and bats, and you can see the internal structures between them are very similar. Each limb has a humerus, a radius, and an ulna, carpals, metacarpals, and phalanges. What's different, though, are the proportions and shapes of these structures. Here's the thing, though. Each of these organisms uses their forelimbs differently. Humans walk on two legs and mostly use their arms for grasping. Cats walk. That depends on their front paws for walking. Whales depend on their flippers for swimming, and bat forelimbs are wings for flying. Even though the underlying structures are the same, the structures have evolved to fit the natural needs of that organism to survive. So Darwin used this evidence of homologous anatomical structures. You see, these organisms all have the same building blocks, arm bones, and that's a good indicator that they're all related. But over time, the building blocks have been shaped by nature to be suitable for their unique environmental conditions. Again, Darwin uses evidence to show the role of nature in natural selection. Scientists today use homologous structures as the gold standard to show relatedness, but scientists today don't rely on anatomical homology as much as molecular homology. The DNA, RNA, and protein sequences are known for many organisms, and so scientists compare the sequences to piece together the story of evolution. Unfortunately for Darwin, these molecules weren't as well understood during his lifetime. So molecular homology was not evidence that Darwin could use. In fact, I don't think Darwin even knew what DNA was. So let's recap. We talked about Lamarck, who proposed an incorrect mechanism of evolution, the theory of acquired traits. Instead, Darwin's theory of evolution by natural selection is the most widely accepted today. Part of that is because Darwin used 4 lines of scientific evidence to support natural selection. Using artificial selection as evidence confirmed how differential breeding or selection can shape organisms and cause evolution. Island biogeography and homologous anatomical structures both highlighted the role of natural conditions in shaping organisms through evolution. Finally, fossils gave people a visual timeline that natural selection and evolution takes millions of years to take place.